Let's break down the essential properties of trigonometric graphs. We will look at the standard forms. Y equals a times the sine of bx minus c plus d and the cosine equivalent. First is the period, which is the length of one full wave. We calculate this by dividing 360 degrees by the coefficient b. Next is the step. This tells us how far to move along the x-axis for each key point. Just divide the period by 4. Property 3 is the amplitude, which is the absolute value of A. If you haven't heard of absolute value before, it simply means the distance from 0. In practical terms, you just drop any negative sign. So, whether A is 3 or negative 3, the amplitude is always a positive 3. To find the maximum height of the graph, we take our vertical shift d and add the amplitude. Similarly, to find the minimum point, we take d and subtract the amplitude. The baseline is the horizontal center of our wave. Its equation is simply y equals d. The horizontal offset is where our standard pattern starts. To find it, take the inside of the parenthesis, set bx minus c equal to 0, and solve for x. Finally, as a handy check, you can also calculate the amplitude by taking the maximum, subtracting the minimum, and dividing the whole thing by 2. Remembering these when dealing with trigonometric graphs will make your life so much easier, trust me. Let's put this into practice with an example calculation. Y equals 3 times the sine of 2x minus 90 degrees plus 1. First, let's identify our key numbers. R is 3, B is 2, C is 90 degrees, and D is 1. Our period is 360 degrees divided by our B value of 2, which gives us 180 degrees. Our step is the period 180 degrees divided by 4, which equals 45 degrees. The amplitude is the absolute value of 3, which remains simply 3. Our maximum is our D value of 1 plus our amplitude of 3, reaching a peak of 4. Our minimum is 1 minus 3, dropping down to negative 2. Our baseline is the horizontal line, y equals 1. To find our starting offset, we set 2x minus 90 degrees equal to 0. Solving for x, we get our starting point at 45 degrees. And just to verify our amplitude, our maximum of 4 minus our minimum of negative 2 gives us 6. Divide that by 2, and we get an amplitude of 3, which perfectly matches our earlier calculation. I wonder, can you sketch this graph?